Hello there, let's talk about some advanced features of DNS. So at first, we have to know DNS basics. DNS converts human readable domain names into IP addresses. This is because domain names are much easier to remember than IP addresses. This process may take place through a local cache or through a zone file that is present on the server. A zone file is a file on the server that contains entries for different resource records. These records can provide us a bunch of information about the domain. We will look more into resource records and the zone file in the next section. So let's understand how DNS resolution works. Let's say the user opens up the browser and types in info.sense.com. It is now the responsibility of DNS resolver in the user's operating system to fetch the IP addresses. It first checks its local cache to see if it can find a record for the queried domain name. A cache usually contains a mapping of IP addresses to host names which are saved during recent lookups so that the resolver does not have to fetch the IP address again and again. If it can't find the IP address in its cache, it queries the DNS server to see if it has a record for it. A DNS server is usually given to you by the ISP. You can manually set up a DNS server for yourself. If it can't find the IP address, then it goes through a process or recursive DNS query in which it queries different name servers to get the IP address of the domain. As soon as it finds the IP address, it returns the IP address back to the user and also caches it for its future use. So DNS lookup and reverse DNS lookup. So what is DNS lookup and what it how could it work? Let's platform a DNS lookup ourselves for a website, and we'll do this by traversing the entire DNS hatchery from the root servers to the top level domain. Open the terminal in Backtrack. You can use your own favorite website and type in dig, just dig. You will get something like the answer section, question section, some information by giving command dig. Performing reverse DNS lookup converts an IP address into its host name. For this, we need to write the IP address in reverse order and then append in addr.arpa to it. Next, we need to make a query for a PTR record using dig. Let's make a DNA PTR query for a IP address, and the command would be dig IP address in -addr.arp capital PTR. One important advanced feature of DNS or and this is DNS brute forcing. DNS zone transfers may not work all the time. In fact, it will not work most of the time. Most of the DNS servers are properly configured and do not allow zone transfers to every client. Well, what do we do then? Simply answer the same thing we do when nothing works: brute force it. Basically, we have a word list containing a huge list of hosts. We first check for wildcard entries by checking if a random subdomain 132q dssac at .example.com resolves to the same IP address as explain.com. If this is the case, we know wildcard entries are set. We then query the domain by using each of the word in our word list. For example, if one of the entries in the word list file is ads, then we will make a query for ads.example.com, and if it resolves to a different IP address, then we are sure that this subdomain actually exists. Hence, we now have information about the name of subdomain and its IP address. If wildcard entries are not set, we do the same thing and see if we get a response from any subdomain we query. If we get a response back, we could be sure that the subdomain actually exists. In the end, what we get is a bunch of information about the subdomain, about the domain. So now let's talk about why is DNS zone transfer needed. DNS is a critical service. If a DNS server for a zone is not working and cached information has expired, the domain is inaccessible to all services. Therefore, each zone should have at least two DNS servers. For more critical zones, there may be even more. However, a zone may be large and may require frequent changes. If you manually edit zone data on each server separately, it takes a lot of time and there is a lot of potential for a mistake, and this is why DNS zone transfer is needed. You can use different mechanisms for DNS zone transfer, but the simplest one is AXFR. Technically speaking, AXFR refers to the protocol used during a zone transfer. It is a client initialized request. Transfers can be performed using a variety of DNS tools, including the NS lookup utility discussed earlier. To perform a zone transfer with NS lookup, follow these steps like set, find the target domain's primary name server. This can be accomplished by typing setq equal hinfo and then querying the domain name. After the domain's primary name server has been determined, set ns lookup to use it, and this is done by typing server target underscore server, where target underscore server is the target domain server. To perform a zone transfer, type set q equal any and then lsd target domain. This will output the records that were received by the zone transfer. With all of the DNS information, it is possible to determine a lot about the network that uses that domain. In addition to discovering internal addressing schemes, it is possible to determine what specific hosts are used for analyzing zone transfer. One more thing is full transfer. When you bring a new DNS server online and configure, it will perform a full transfer of all the zone information in order to replicate all the existing resource records for that zone. Older implementations of the DNS service also used full transfers whenever updates to a DNS database needed to be propagated. Full zone transfers can be very time consuming and resource intensive, especially in situations where there isn't sufficient bandwidth between primary and secondary DNS servers. For this reason, incremental DNS transfer were developed. So this is it, guys. Hope you guys liked it. Thanks for watching.